Hello and welcome to another one of D's ADD videos. Today we're going to look at limits involving sine and cosine. The main thing you're going to try to do is try to set up these basic identities. First of which is limit as something approaches 0 as long as it's the sine of that something over that same exact something that'll equal 1. Or if it's that something over the sine of that exact same something, as long as they're both going to 0, it'll also equal 1. Now the cosine identity is a little different. It equals 0, and it's 1 minus cosine of something over that same something. So let's see it in action. Here we're going to look at this first rule. There should be a parentheses around this right here. I apologize for that. This is all the argument of the sine in the numerator here. And then that's not. That x is separate. So, if I was looking at this problem, the first thing would be to plug in, and you're going to get 0 over 0. Sine of 0 plus 0 is sine of 0, which is 0, and that goes to 0. I can't use that identity quite yet because this expression does not look exactly like this thing in the denominator. You see how these stars are the same thing? So what you got to do is, once you write down 0 over 0 and I and D, you got to manipulate it somehow to try to get the same thing in top and bottom. So what you're going to do is you're going to multiply the top and bottom by that expression, and then algebraically manipulate it to where you have the same thing over the same thing, like I do here. Here, and I can then take this 4x plus 2 in the numerator and I can bring it off to the side here. Okay, so I'm selectively grouping the sign of that argument which I had with this new expression, and note this equals 1, right? So I'm not really changing the problem, I'm just rewriting it. And when I do so, I can look at the limit of the product as the product of the limits, meaning if I got two things multiplied together and I'm taking the limit of them, I can take the limit of each one individually. And when I do so, this is now my star over star. They're exactly the same. They're both going to 0. Okay? If you wanted, you could do a substitution where you let t equal all that, and then as x approaches 0, t will also approach 0. I'll show you an example later whenever we're doing these example videos. But here in this problem, this will go to 1, this second expression, using that identity that we just went over of sine star over star. This one, if you were to plug in right now, it would still give you 0 over 0. So then you separate these, make it 4x squared over x plus 2x over x, which then simplifies to this plus this, which if you plug in a 0 will give you 2. Alright? So that's the sine example one. Yes, I am doing example videos in a concept, but there's no really succinct way to explain these without just really doing it. So here is a 1 minus cosine of something over something example. We're starting out with a sine, okay? So if you really wanted to, you could do the sine 4x, multiply this by 4 and top by 4, and then you need to do 4x over 4x again. But let's try something different. So if we're doing it this way, we use the identity. We know the Pythagorean identity of sine squared 4x plus cosine squared 4x equals 1. Solve for sine squared, you'll get that. And then that's a difference of 2 squares that will factor into this. And then you can do the limit of the products equals the product of the limits, and you selectively group the x with the 1 minus sign, right? So that way when you multiply, all you have to do is multiply by 4 over 4 to get this expression to be the same thing as that expression. I need a 4 in the bottom. So when I bring in that 4 in the bottom right here, I have to multiply times the top as well. So then the first expression goes to 0, That's 4 times some other expression. Cosine of 0 is 1. 1 plus 1 is 2 times 4 gives you 8. But it doesn't matter. Why? Because this whole first expression here equals 0. So 0 times anything is 0, and you're done. So this is a concept and example video. I will do a couple more example videos for trig identity limits. Other than these identities, just try to evaluate them, maybe use some trig identities of pre-calculus and trigonometry to maybe give it a better appearance, make the problem a little easier. I hope I've eliminated any doubts you might have. As always, you need to practice as much as you can to get a hang of this. Thank you, and have a nice day.